So, unfortunately, I don't have time to do one recording session for one full 50 lecture. I'm going to have to break this into two pieces. The first piece will be going over the test that we took, and then the next piece I will record later today and upload later. But I'll make sure to get 50 minutes of lecture uploaded and the links sent to you. Anyway, this is the test that we did. So So looking here, we have to figure out x and y intercepts, vertical asymptotes, horizontal asymptotes, slant asymptotes of this function. So the the y-intercept is found by plugging 0 in for x. If I do that, f of 0 equals 0. This is 0. This is 0. Put in zeros here, we get 2 times negative 6 squared times third over 4 times negative 1 times negative 3 squared. I cancel a 4. This is 8, so now it's 2. I cancel 2 3s with these 2 3s. Now this is squared. This gives me 2 times 2 squared, so that times 4 is 8, times 2 is 15. Just a second. And there's this negative 1 here, making it negative 6. So our y-intercept is going to be at negative 16. And so we're going to have to make the squares worth a little bit more than 1. Um, just for the sake of making the graph more compact, let's say that each of these boxes vertically is going to be here. Will be 16 here, and we'll color the dot there. Negative 8. Now we need to find our x-intercepts. They will be at positive 6 and negative 2. And we can make the horizontal grid wider. So we have one at 6 and one at negative. The vertical asymptotes are found by the roots of the denominator. We have one at negative 4 here. Can't scroll and draw at the same. 4, negative 4, positive 1, and positive 3. So 1, 3, drawn. And let's look. 4, 1, 3 are labeled. Those are all labeled. So is this. Okay. Because the degree on the top is 5 and the degree on the bottom is 4, we do not have a horizontal. Instead, we have a slant asymptote. And to find that, we're going to need to do some long division. So, you have the privilege of being able to look at the top of the paper at the same time that you look. There we go. Okay, so now I can scroll down, use my space here to find out that value. I have to do long division. Fourth minus third minus 13 squared plus 51 x 6 into 2x to the fifth minus 12x to the fourth minus 48x third plus 1x squared plus 70x minus 5 x to the fourth goes into 2x to the fifth, 2x times. 2x times this gives us 2x to the fifth minus 6x fourth minus third plus 102 squared minus 30x and subtract gives us negative 12 minus negative 6 is negative 6 because negatives negative 6x to the fourth comes 48x to the third minus 20x or plus 20 20x to the third and so on. And we don't really need any of the other terms because the next step is to say, well, how many times does x to the fourth go into negative 6? X to the goes into negative 6 times. Negative 6 times this gives us 6x fourth plus 8 third, and we don't really need the subtract. Now we get negative 6x to the fourth plus 6x 0, and everything else is going to be 3 or lower. You don't need to. And this is our slant asymptote. Y equals 2x minus. Scroll up to here. Here's minus 6. Need a slope of 2. So we've played a little bit around with the aspect ratio, but that means if it goes up 2, slope of 2, that means that to get up to the x-axis, we have to go over 3, so that would be here, 3, 0, and here our slant asymptote. So that we have y equals 6. We want to figure out where it hits the x-asymptote. Plug 0 in for y, x minus 6, sides. This is the other asymptote, sorry, the other intercept of the line. Mark this as y equals x minus 6. And now we have all of our features. So we start off at negative, and we were going this way towards this negative asymptote. So bend down. Okay. This is the asymptote that goes with that factor, which is to the first power, which is odd. So we come down from positive infinity with which, and we're positive, and we're headed toward this asymptote at 3. Positive going toward an asymptote means we bend up to positive infinity. This is an even degree asymptote, so we stay the same sign. Come down from positive infinity. We have to hit this root, so we come down to the root. This root is even power, so that means we bounce off of the axis, off of there, and we bend towards the horizontal asymptote, the slant asymptote. In the other direction, we're positive. We have to hit this root. This root is degree 3, so we're going to try and flatten out as we get to it. But it's degree 3, so it's odd, which means we will switch signs to positive after. Positive going towards a asymptote, so we bend up towards positive infinity. This factor corresponds to the asymptote. It has a degree 1, which is odd, so we switch signs and come up from infinity. and we bend along the slant asymptote. That's one of the questions. Next question. According to Descartes' law of signs, how many positive roots and how many negative roots could f have? So let's switch all the signs and all the odd powers like that. Have positive, negative, positive, negative, negative, negative. 1, 2, 3, 4, 5 sign switches. So the number of negative roots is 5. Count down by 2, 3, 1. The number of positive roots is 1 sign. What are the possible roots of f according to the rational roots theorem? Well, the factors of the constant are 1, 4, 8. Factors of the leading coefficient are 1, 3, 9. So we get 1/3, negative 1/3, 2/3, negative 4/3, negative 4/3, 8/3, thirds. We also get 1/9, negative 9th, 2/9, negative 2/9, 4/9, negative 4/9, 8/9. Find the roots. So we copy other screen. Have 9, 5, 3, 38, 4, and 8. And we'll try 1 as our first root. So 9, 48, 48, 103, 141, 4. Am I adding? Let me just redo. Not sure exactly where I. So we have 9 plus 39 is 8. Here, 5 gives us 90 plus 33. Here, 146 goes here. 146 here. We add 146 to 38, and we get 4. Here, plus 4 gives us 1, 8. That here, and then we get 1, 8. This is an upper bound. That means that everything bigger than 1 that would be 2, 4, 4/3, 8. Let's go again. 9, 39, 5, 40, 38, 4, and 8. Well, oh, and 1 didn't. I guess we'll try negative 1 next. Negative 1, we get 9, negative 9, 30, negative 35, negative 25, negative 8, negative 20. Negative 1 didn't. 9, 39, 5, 38, 4, and negative 9, negative 8. Thus, 2, 6, borrow there, 7, 1, 4, 4, -8, -4, +8. That one worked. Here. -2 worked. Our constant has changed. Delete all of the 8s on the top of it. Yeah. Try again. 2, 9, -8, 3, -6, 7, 6, +4, and 0. So that was a double root. And the end is now -2. Cancel everything that has. Okay, let's try doing it again. Get 9, -8, 30, 7, -74, -71, +1, 42, 140. This is a lower as the alternating. Smaller than negative. Unfortunately, that copy our numbers down again. 9, 7, -2, 3, -3, -1, +1. This already wrote -1. -1/3 times 9 gives us 3. -7. 9/3 -9. That is get a lower. That was right down because copy total 9, 6, 0. Good. So 1. Get anything cool out of that? Upper bound bigger than 1/3. Thirds is bigger than 1/3. Good. But we now have a cubic, so 9x cubed plus squared plus 6, which we can factor as x out of x plus 2, x plus 3, 2, that factor squared plus 3 times 2. This one has a factor of -2/3. Set it equal to 0, so we write that up in our. This one here we set equal to 0. Divide by 3. Squared plus 1 equals 0. X squared equals 1. X equals plus or minus 1, which is I, and those are our last two roots. That's the end. Anyway, look out for the next video. It'll probably be recorded late tonight. Well, have grades posted for those on campus. Great day. Bye.